Magic button. Yay. So that's what I heard at the end of class. It's gonna like look at me. Maybe I should have the camera somewhere close to on there. Okay. How exciting. Okay, so has anybody started their Khan Academy problems? Like Kids Start? Have you? Can you give me a problem that is on your screen right now, like in the exercises? Okay, so those, I'm going to give you permission to use calculator. And there's calculator on there. I'm going to have you skip to converting repeating decimals to fractions. So anything changing a fraction to a decimal, just divide on a calculator. Okay. So where we're going is, I'm going to write the heading up here. So there's a part of this that's really easy, like just one thing you got to know, and then there's a part of this that's like, it is algebra. Yeah. So in the future, thanks for asking. In the future, if I take time to write it on here, it's important enough. It means that you're writing it. So what I need is one of these kinds of problems.
You said 0.3.
Is it repeating? Has it got a little line over it?
Yeah.
Okay. So that's called a repetend, and it means it goes on forever. So it actually means this is going on. Right? Okay. So converting this to a fraction, this is the easy part. And the deal is, if you have a one-digit repeater, the denominator which is the bottom number, is 9 every time. So that's been the main thing people have asked about. Every time you have a repeater decimal, the bottom number is 9. You have all that written? Like you want to be done as close to when I'm done as possible so we can keep going. So this is a fraction that has a 9 in the bottom, and the 3 actually is the top number. So the repeating decimal is the top number, and 9 is always the bottom on a single repeater. Now this isn't what Khan Academy is looking for. They're looking for the simplified. So they want these numbers to be as small as possible. So we divide stuff out. It's kind of like squeezing a sponge. We kind of squeeze as much out as we can. We're going to squeeze a 3 out of both the top and bottom. So 3 divided by 3 is 1, and 9 divided by 3 is 3. And that's the number, that's the answer that Khan Academy is looking for. So if you could put in a 1/3, and you can have your sound on, and we'll be able to tell if it gives you a twinkle noise.
How am I supposed to do it?
They have a picture of fraction in there.
No.
And do the slash. Yeah. When I did it, they had like fraction boxes.
Yeah, I said right for it. But it didn't do it for what I wanted.
Can you say that again?
It said it's correct.
So unmute your sound and we'll see if that'll work. Okay, so that's the fast part about single digit repeater. So what's the next problem?
1.83. And the 3 is repeated.
Now, I think I'm gonna hold off on this one because it's a lot harder than the next ones. And we'll come back to it.
Let's skip it.
I guess. You can skip. Say 0 and go on.
It says try again.
Yes, let's try again.
Okay. Say 11 over 6. Okay, so keep going.
Okay, 3.16. And the 6 is repeated.
Okay, we're in the hard stuff here. We're gonna do it. So we'll use this one for the long set of notes. So we're gonna roll. So this goes with the video that Han did on the site. Okay, so we need to eliminate the repeaters. Using math rules. So that's the deal. We need to eliminate using math rules. Okay, so there you go. And gosh. Okay. So this has to go. And we're going to use subtraction. Of two equations. So we're going to use subtraction of two equations to get rid of that 6 that keeps going on forever. So if my number goes out of sight, I rewrite it and I'll call that the original. There's an invisible thing here that's something we can do. It's invisible. We're going to use it. We're going to make this into an equation, x equals 3.16. And this unknown here is our fraction. So once we get all done with this, we're going to have x equals some fraction. That'll be our answer. Let's go take a look. So we're going to subtract a small equation from a big equation. Let's see what angle I want to have on this. There we go. It's just kind of distracting. Okay. So we need to move this decimal point. So that the repeater is by itself on the right side of the decimal point. could scroll. So that's the first equation. We got to move that decimal point so that this repeater's by itself and the decimal point's right there. So so I asked myself, that's what I asked myself in this. How many decimal places over does that decimal point have to go? So I'm going to write my original again. X equals 3.16 repeating. Now it's got to go over so that this repeater is all by itself. So it's got to go to here. How many places over is that?
One.
Who agrees with that? One place over to get from there to there. Okay? You have to decide on that because every place over that you move a decimal point is a multiplier of 10. So that's why you have to know how many places because it's a multiplier of 10. Right. So the next thing I'm going to do is make sure you have everything I've written. Okay? So here's our strategy. Ten times x, 10 times 3.16 repeating, and here's our results. 10x equals 31.6 repeating. So that's what needed to happen. That 6 with the bar over it needed to be by itself on the right-hand side of the decimal point. So we got that done. And we followed the math rules. That's our small equation. So we're going to create a large equation, the large value equation, using math rules. To subtract from. Because that's how we'll get rid of the repeaters, is subtracting them out. Okay. So we got to create something even bigger than 10 times x. I'm going to write my original again, out of sight. What was it, 3.16 repeating?
Yeah.
Okay. That's probably why I wrote 3. Okay, so now, just remember there's like endless amounts of 6s. So if I keep moving my decimal point, there's still going to be 6s on the right. Yeah. Until I eliminate them. So on the bigger equation, I need one repeater on the left. So we have to create an equation that has one of those sixes on the left. So we ask ourselves, how many moves of this will it take? Boom, we gotta be right there. How many moves was that? Well, each move is a multiplier of 10. So it'll be a 10 times 10. Yeah. So I'm gonna write that. So we're going to multiply this guy 10 to 100. So here's our strategy. Um, 100 times x and 100 times the 3.1666. That's our strategy. So in algebra, if you do some multiplier to one side of your equation that's true, you have to do it on both sides to keep your equation true. That's what we do. We deal in truth in mathematics once we follow the rules. Wow. Oh no. Got it. Okay. So that's our strategy. And the next line, this always happens in algebra. The next line is your results. So 100x equals, now remember, when we multiply by 2 10 multipliers, we get to go over 2 places. And now those 6's would just keep going. So here's my big equation. I think this is only supposed to be oh yeah, okay. And my small equation was 10x equals, so the small equation has the repeaters by themselves. The big equation has one of the repeaters with the other numbers. So that's how you would always do this. And sometimes it'll be 3 moves. So sometimes this will be 1,000. If it's 3 moves, it's 1,000. Okay, now this is where we get to do our takeaway. Yay, we're gonna takeaway. We're gonna eliminate takeaway. Okay, 100 minus 10. Who agrees with that? Dollar minus 10 cents. 90 cents. So when you are adding or subtracting x terms, just deal with the numbers and the x comes along. The x just comes along. This will be normal subtraction here. And these guys, here's actually why we're doing this whole thing, is so that we can do 0.6 repeating minus 0.6 repeating. That's why we do this whole thing. 0.6 repeating, take away 0.6 repeating, and that means it's eliminated, it's gone. And that is a big deal in algebra. Eliminated. Super. Now we're just down to regular numbers, and now we'll get a fraction answer here in just a minute. 6 minus 1, we got to borrow from the 3. 11 minus 3 is 8. There we go. And we're going to find out what x is worth, and I'm going to talk about when an equation looks like this. 90x equals 285. For one, there's an invisible dot right there. That's actually 90 times x equals 285. And so I want you to look at this equation, 90x equals 285. And I want you to notice there's no plus sign. No plus sign. So in my magic 7 steps of solving, which is on this poster, did I give you guys the little handout? No? So last year we made this poster together in my 8th grade class. And we just started one step at a time kind of thing. Step 7 is, I'm going to read it to you. When there is no plus signs, you're almost done with solving when there's no plus signs. When there's no plus signs, look for the letter. So you always look for the letter at the last step. If there's a number by the letter, divide both sides of the equation by that number. So look for the letter. What number is beside the letter? We're going to divide both sides by 90. So that's always the 7th step in solving. When all the plus signs are gone, we're almost done. So they call this one-step solving right here. But all this other stuff with it. This one-step solving. This number, we're going to divide both sides by that number. Any number divided by itself is close.
It's itself. Or no, like,
One.
I was thinking about.
You guys, I know exactly why you're saying all these answers, so good thinking. The 0 is the identity number for adding. So if you get rid of something, it becomes a 0. But when you're dividing, it becomes a 1. So 1 is the identity number for dividing. 0 is the identity number for adding. So any number divided by itself is 1, but I also know why you said it so. So you guys are thinking. But any number divided by itself is 1. So in algebra, our last step, we always get a 1x. Because that's why we do it. And this is actually our answer, this ratio. So in algebra, your answer will usually be a ratio. Sometimes it'll be a 1 under there or whatever. This is the answer, but it's not simplified yet. So if you use a calculator, this will get a decimal, it'll get 3.16 repeating. So we don't want to use a calculator for that. We want to keep it as a fraction. So we'll look at it, and what number do you think could divide out of there? I call it like, we're going to kind of squeeze these numbers down to smaller numbers. So the main clue's right here, you guys. So listen while I skip count by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Notice when I count by 5s, they always end in 0 or 5. So that tells me these will, I can divide out a 5 top and bottom. So 285 divided by 5, you can use calculator for that part. However you want to do. Anybody got it yet?
57.
Anybody agree with 57?
Yeah.
So it's going to be my numerator. And then 90 divided by 5. That'd be 50 divided by 5. You know how I do it? Since you're trying the mental math, there's a way. Okay. Oh, if I don't lose it, there's a way. That's right. So I want to show you my shortcut. I go 5 into 9 goes how many, and I write the answer. And then I think 9 minus 5 is 4. So my remainder I put right there. And 5 into 40. So this is like my shortcut for dividing. I put the remainder on the next number. And then I just keep going. So I agree with 18. 57 is prime, so nothing else fits in it. So that is the answer that Khan Academy wants. And they will have this problem on yours. So if you write it down, it'll be good.
How do you remember all this?
Yeah. Repetition. I'll put that one. Repetition. And really, I like doing it because if you know the right rules, you can always get the right answer. So that appeals to me. So that actually goes with Khan Academy video. Now we're going to go with the next problem he has because we're just going to work through these problems that you're going to get. And so if you'll take good notes, you'll have the answers to the problems on Khan Academy.
0.83.
What's repeating?
The 3.
Okay. I think this one's going to go faster because it's smaller. So we need to move the decimal point one place. So what's our multiplier?
And then
So we're going to get 10x equals 0.83 repeating times 10. So 10x equals, now that will move us over. This right here moves our decimal one place. And see how our repeater's all by itself? So that's our small equation. And then we need to have one of the 3's with the 8 and all the other 3's. Just remember, there's a whole ton of them. We need all the rest of them here. So how many moves is that?
100.
How many moves?
2.
So our multiplier is, if it was 100 moves, our multiplier would have 100 zeros on it. It's a really big number. I don't know what number that is. So my original, because I can't see it, I'm going to rewrite it. Is that what it was? Yeah. So we're going to go 2 moves because we have all these other 3's over here. So we're going to do times 100. So I guess I got to write my original again. I'm going to put my strategy. Whoops, sorry. What's a noun? Watch this. It's going to be so big. Yeah, watch this. It won't even be anything. No. Anyway, because the screencast applies right next to each other. Okay, this is where the decimal goes. We decided we're going to move it 2 places. So our strategy is 100 times x. This means 2 moves. This is our strategy. So our results is 100x. And this will move over 2 places, so it's 83. Then all the 3's are over there, but we have one of the repeaters on the left. So that's our large equation. And we needed a big equation and a small equation so we can subtract. And that's how we get rid of that repeater. So I'm going to subtract the smaller equation. Now line up your decimal points, you guys. Don't put the 8 under the 8. Put the decimal point there, and that 8 will go into the 3. And then these will all go here, and that's really good because those are going to subtract out. So these guys are going to eliminate. Whenever we subtract a number from itself, that's when we get the 0. So when you divide a number by itself, you get a 1. When you subtract a number from itself, you get a 0. And that means it's gone. So 100 minus 10, we know that's 90. And now we just subtract these whole numbers. So it's, we gotta borrow for the 3. So we have 13 minus 8, 7, and now we have whole numbers. And that's what we wanted, you guys. That's actually the reason we do all of this. So we're on step 7. See how there's no plus signs there? Step 7, look for the letter. Look for the number that's with the letter and divide both sides by that number. So we're going to divide by this number. And this will always be a 1. And this is actually the answer, but it's not simplified yet. So in algebra, your last ratio is always your answer, but it might not be simplified. So what can we squeeze out of these guys? I think so. A 3 and a 5, we can squeeze out a 3 and a 5. No, 15 doesn't go in 75. Yes, it does. Yes, it does. It goes in 5. Wow. Good job. So 15 to, and you, wait a minute, this will be a 25, right? Oh, I'm taking out a 15 though. So 5 would go in 25 times, and then 3 would go in 25 times, and 5 would go in 5. So that's where the 15 comes from. So 15 goes into both of these. You could divide by 5 and then divide by 3 and still get the same answer. So we agree this will be a 5 on top. And what do you think it is on the bottom? 90 divided by 15. You could use calculator. Everybody agree with 6? So 5/6 is 0.83 repeating. How fun. Okay, now we're going to do as many as we can so you have as many answers as you can get. So what's the next one? So I hope you put 5/6 in there before we do that.
3.2 and 2 is repeated.
So this will go fast. So just look at this. If we have 2 repeating, do you remember the rule? What's the bottom number?
9.
What's the top number? Yep. So this value is 3 and 2/9, but Khan Academy wants that in a fraction. So we got to learn how, well, I got to remind you how to change a mixed number to a fraction. Multiply your integer times the bottom and then add the top. This gives you a new top number. So the new top number is the integer, that's the big number, times the bottom, plus the top, plus the old top. So the new top number is the integer times the bottom number plus the old top number. So 3 times 9 plus 2, raise your hand if you know. Well, raise your hand if you know. Because because you're a fast thinker, and then if you say it, their brain will just like pause, you know. So who knows? You'll raise your hand, I'll know if you know, but I'll know that you probably know. So who agrees with 29? 3 times 9 is 27 plus 2, 29. So that's our new top number. And then just keep the bottom number. And this is what Khan Academy is looking for. They're calling that a simplified fraction. So this is a mixed number. And this is what they're calling a simplified fraction. I always knew this as an improper fraction.
What would we do if there was no 3, only 0.2?
then it's 2 ninths. Yeah. If there's no whole number, then it's just ninths.
Because it's repeated, so it would just turn to a fraction.
Yes. Any single digit repeater is a ninth. That's a great question because he's like, is that always true? And it's a fair question in math to ask, is that always true? Because we love always. Doesn't always happen. Next one.
One point six and 6 is repeated.
Okay, so this will be pretty easy. We won't, because there's no non-repeaters here, we're just going to think about this one first. So what's that one? Yeah. And then bring the whole number down and then change it. And actually 6 ninths right here, we might squeeze out the 3s. So it'd be even faster to squeeze out the 3s and then just multiply and get the new top number. Because it's just small, easier numbers. So what's the new top number? 1 times 3 plus 2. Oh, there's a 5. Got it? And keep the old number, and that is what Khan Academy is looking for.
2.8 and the 8 is repeated.
It just be the same.
Just keep going. So think about that first, as long as there's nothing else with it that doesn't repeat, as long as it's a single repeater. What fraction is it? Yep. Bring this guy down, this integer down. You're already done, right? Sometimes, if somebody gives this answer that really surprises me, I call that high voltage math. Sometimes kids really surprise me. I have a feeling you're gonna really surprise me later. So what's our new top
Thank you,
number?
students. Sorry for the interruption. Just want to tell everybody nice job this week. It's a whole different situation for us. You guys have done a great job. So
18.
keep up the good work, and next week we'll pick it up again.
That's what Khan Academy is looking for. So we're gonna have 3 days next week. But if you wanna work on it and get these parts done, but I will see you guys Tuesday. Like the first day back, I'll see you guys. All right. Stop.